Volt-ampere characteristics of PN junction diode. Before this, let's look at that a PN junction diode. A PN junction is called as PN junction diode or a semiconductor diode. This is also called as crystal diode because it is formed in a crystal. A PN junction diode is an unidirectional two-terminal semiconductor device. It conducts only in one direction and offers high resistance in other direction. Circuit symbol of a diode. When diode is used as a circuit element, it is convenient to represent it by a symbol. The two terminals of the diode are called anode and cathode. The p-type region is called the anode and the n-type region is called the cathode. The arrowed head in the symbol points from the p region towards to the n region. This shows that the direction of conventional current is from the p region to the n region, which is also the direction of flow of holes. If diode is used as a circuit element in an electrical circuit, there may be a requirement to know how it is responds or behaves in electric circuit. This type of information may be obtained by a curve known as volt-ampere characteristics of a practical diode. The VI characteristics of a diode is simply a curve or a graph between the voltage applied across its terminals and the current that flows through the diode due to this applied voltage. The entire VI characteristics may be divided into two parts, namely forward characteristics and reverse characteristics. The forward characteristics. This figure is used in a laboratory to obtain forward characteristics of a diode. The diode in the circuit is in forward bias state because the battery VFF is pushing the current in the direction of the arrowed head. In the circuit, the battery VFF is connected to the diode through potentiometer P. The potentiometer helps in varying the voltage across the diode. The load resistance RL is used in the circuit to limit the current through the diode. A voltmeter is connected across the diode to measure the voltage. A milliammeter is also connected to measure the current in the circuit. To plot the characteristics, the voltage across the diode is increased gradually and corresponding increase in the current is noted. The graph is plotted by taking voltage on the horizontal axis and current on the vertical axis. A careful look at the forward characteristics reveals the fact that up to point P, the diode current is very small. This is so because the applied voltage has to overcome the barrier potential and the diode conducts poorly. Once the applied voltage is slightly greater than the barrier potential, the diode current increases rapidly and diode conducts heavily. This voltage at which the current starts increasing is called knee voltage, that is V0. Its value is 0.7 volts for silicon diode and 0.3 volts for a germanium diode. The applied voltage across the diode should not increase beyond the specified safe value, otherwise the diode will burn out due to heat. This specified safe value is provided by the manufacturer for each type of the diode. Reverse characteristics. This figure is used in the laboratory to obtain reverse characteristics of a diode. The diode in the circuit is in reverse bias state because The battery VRR is pushing the current in the direction opposite to the arrowed head. In this circuit, the battery VRR is connected to the diode through potentiometer P. The potentiometer helps in varying the voltage across the diode. A voltmeter is connected across the diode to measure the voltage. A microammeter is also connected to measure the current in the circuit. A careful look at the reverse characteristics reveals the fact that below the breakdown voltage, the diode current is very small and almost remains constant. This current is also called reverse saturation current I0. It is of in the order of microamperes for germanium diode and nanoamperes for silicon diode. It is due to the movement of minority carriers which are thermally generated. It means that reverse bias current is temperature dependent and does not depend upon the applied reverse bias voltage. But if a large reverse bias voltage is applied across, known as junction breakdown occurs. Due to this, the diode reverse current increases rapidly. The applied reverse bias voltage at which this occurs is called breakdown voltage VB of a diode.